the 5 ways that we've used to show that a quadrilateral is a parallelogram? Well, here they are one more time. Okay? Now, as I mentioned before, we're gonna do a fourth and final example problem where perhaps one of these ways is going to be used to help us solve that problem. Take a look. What we have here is, what I've done is I've written down the 4 coordinates of a quadrilateral, K, L, M, and N. I've written down the numbers right there where they're located, the coordinates, and I've drawn the picture right here on this graph. Okay? What we must do, of course, is prove that this quadrilateral is a parallelogram. Okay? Now, we just saw the 5 ways to prove that a quadrilateral is a parallelogram. So the question now is, which way do we use? Okay? It's kind of a tough one, but when you think about it, it's really an easy choice. Look at number 4. Number 4 was one pair of opposite sides are congruent and parallel. So we know we have a grid here. So if we want to prove that they're congruent, then we can use the distance formula. If we want to prove that they're parallel, then we can use the properties of slope. Okay? Remember the word slope? It's been a little bit. So we'll go back over it in just a moment. But those are the 2 things that we need: distance formula and using slope. And if we can use those 2 formulas to the right way, then we can show that this shape right here is indeed a parallelogram. So we'll first start off by finding the distance of each of 2 sides. Now, for the sake of argument, it doesn't really matter which 2 sides you use as long as they're opposite each other. Okay? What I'm going to use is, I'm going to use the segment KL and NM. Okay? We're going to find the distance formula first for both of those, or use the distance formula for both of those, and then find the slope. So, let's do the work over here.